In this question we are told that L has a gradient of -1 and that it is tangent to the graph of f at Q. We have to find the exact coordinates of Q. An important key word in this question is exact. Let's see what this word means here. Let's say that you solve an equation and you get that the answer, so for example x, is equal to the square root of 2. If you solve this equation using a calculator, you will get that x is approximately 1.414. So the exact solution for this equation is square root of 2, and the rounded, so non-exact solution is 1.414. What the word exact tells us here is that even though we are allowed to use a calculator, we should find a solution without using a calculator in order to get the exact answer. Of course, we can then use our calculator to check if our working was correct. Let's get started. The first key piece of information is that L is tangent to fx at Q and that the gradient of L is -1. Now this information tells us that the derivative of fx at Q is equal to -1. So let's differentiate fx. This law from section 5.6 of the formula booklet shows us that the derivative of e to the power of x is simply e to the power of x. So for the derivative of fx, we get 90 times e to the power of -0.5x. However, since in the power of e we have -0.5x, we'll also use the chain rule from the same section of the formula booklet, because fx is a composite function, where our inside function is -0.5x. So when we are looking for the derivative of fx, we'll multiply by the derivative of the inside function, so the derivative of -0.5x. This derivative is simply -0.5, so here we'll multiply by -0.5. 90 times -0.5 is -45, so we get that the derivative is -45 e to the power of -0.5x. We figured out earlier that the derivative at Q is -1. So in our next step, we'll equal the derivative to -1, getting that -45 e to the power of -0.5x is equal to -1. Dividing by -45 gives us that e to the power of -0.5x is equal to 1 over 45. And now using this concept from section 1.5 of the formula booklet, we'll change our equation from exponential into logarithmic form. Since log base e is ln, we get that -0.5x is equal to ln 1 over 45. Expressing 1 over 45 using a negative power, we get that -0.5x is equal to ln 45 to the power of -1. I have done this because in our next step we'll use this logarithmic law from section 1.7 of the formula booklet. This law tells us that we can take the power out from the logarithm and put it in front of the logarithm, which gives us that -0.5x is equal to -ln 45. From here, we just have to divide by -0.5 on both sides, which is the same as multiplying by -2. So we get that x is equal to 2 ln 45. This is the x-coordinate of Q. So in our final step, let's find the y-coordinate. To do so, we'll substitute 2 ln 45 for x into the expression for fx. This gives us that y is equal to 90 times e to the power of -0.5 multiplied by 2 ln 45. 0.5 times 2 is 1, so we can cancel these two numbers. Using the logarithmic law from section 1.7 that we used earlier, we can move the -1 from front of the ln into the power inside the ln, so we get ln 45 to the power of -1, which is the same as ln 1 over 45. Since ln is log base e to the power of ln 1 over 45 is simply equal to 1 over 45. Therefore we get that y is 90 times 1 over 45, so 2. Therefore the exact coordinates of Q are 2 ln 45 and 2. In the beginning of this question, I mentioned the meaning of the word exact in this context. So my exam taking tip is a reminder that when on a paper 2 question you are asked to find the exact answer, it is a hint that you're expected to solve the question without using a calculator. Of course, you can then use your calculator to check whether your solution is correct or not.